Section 3.3, rate of change and slope. Essential question. How do you find the rate of change from a graph or table? Well, rate of change is the change in y over the change in x. This can also be thought of as rise over run. And sometimes it's written as this. Change is a triangle, so change in y over the change in x. All right, so use the graph to find the rate of change from 1995 to 2000 and 2000 to 2005. Is it a constant? So first we're going to figure out the rate of change from 1995 to 2000. So 95 to 2000 are on our x-axis, so the two that I circled. So remember, we want rate of change, so change in y over the change in x. So don't forget, you always want to do y over x. So our change in y, change in x. So if we look at our graph, I'm trying to go from 1995 to 2000. So up here, that would be our change in y, and then over here would be our change in x. So if I look at how many I'm rising, well, I went from 8.1 to 9.0. So I can do 8.1 minus 9.0. Then if I look at my change in x, I'm going from 1995 to 2000. So 1995 minus 2000. Now keep in mind, you can do 8.1 minus 9, or you can do 9 minus 8.1. You can do 1995 minus 2000, or you can do 2000 minus 1995, but you have to stay consistent with which one you do. So 8.1 minus 9 would be a negative 0.9, and 1995 minus 2000 would be a negative 9. So then keep in mind that would be a negative over a negative, so a positive. Positive 0.9 over 5. So that is our rate of change from 1995 to 2000. So that would mean that the departures in millions was 0.9 or 9/10 of a million over 5 years. All right, so then if I do 2000 to 2005, so change in y over change in x. So now I'm going to go from my second group, so change in y over change in x. So I've got 9.0 minus 9.9 over, and I went from 2000 minus 2005. Keep in mind that change is subtraction, so that's why we're always doing subtraction to find the change. 9 minus 0.99 is negative 0.9. 2000 minus 2005 is negative 5. So once we again we have a rate of change of 0.9 over 5. You'll notice that this line is a straight line, so we have the same rate of change. So that means that yes, when I answer this question, is it a constant? The answer is yes, because they have the same rate of change. All right, second one. All right, so this time we're looking at the number of U.S. passports issued. So first we're going to look from 2002 to 2004, and then 2004 to 2006. So 2002 to 2004. So change in y over change in x. So if I start at 2002 and go to 2004, change in y, so I'm going from 7 to 8.9. So 7 minus 8.9. And then I'm going from 2002 to 2004. So 7 minus 8.9 would be negative 1.9. 2002 minus 2004 would be negative 2. So 1.9 over 2. All right, so then if I go to 2004 to 2006, change in y over change in x. So my y values go from 8.9 to 12.1. My x value went from 2004 to 2006. So 8.9 minus 12.1 is negative 3.3. Sorry, negative 3.2. And 2004 minus 2006 would be negative 2. So you'll notice that if you simplify these, 1.9 divided by 2, would be 0.95. Negative 3.2 over negative 2. Be 1.6. So you'll notice that these do not have the same rate of change, and I'll get rid of my work here so that it's a little bit less messy. But the rate of change from 2002 to 2004 was 0.95, meaning there were 0.95 million passports issued from 2002 to 2004. And then that number increased. There were 1.6 million passports issued from 2004 to 2006. So no, it is not constant. Because there were different rates of change. And you'll notice if you looked at the graph, it's not a straight line. It's more gradual there for the 9.95 and then more steep here for the 1.6. All right, now we've got a table. So use the table to find the rate of change and explain its meaning. So when I'm working with a table, I'm still going to do the change in y over the change in x. But I'm going to do that two different times, and I'll show you why in a second. So I always like to start at the bottom of the table and work up. So 228 minus 152. So 228 minus 152 over, and then in that same time period, 6 minus 4. So 6 minus 4 is 2. And then 228 minus 152 is 76. So 76 divided by 2 is 38. So that would mean we could travel 38 miles in an hour. All right, now let's go to the next time period. So 152 to 76. So 152 minus 76. So this one I'll just put here. I got 76, 2 here. And then from 4 to 2, it's 2. 152 minus 76 is 76. So that would again be 38. So both of these had the same rate of change, therefore it is constant. All right, now we've got another table. We'll do the change in y over the change in x. Change in y over change in x. So again, I like to start at the bottom of my table, so from 3 to 2. So 3 minus 2 gives me 1. And then 60 minus 40 equals 20. So 1 over 20. So for every 20 minutes used, the cost is $1. All right, so let's look at the next one. So 2 minus 1 over 40 minus 20, which is going to give us 20 again. So 1 over 20 and 1 over 20. The rate of changes are the same, so therefore it is constant. All right, determine whether the function is linear. So you know that something is linear if there is a constant rate of change. So it's linear if there's a constant rate of change. So again, I'm going to start at the bottom of my table. So 24 minus 18 would give me 6. 4 minus 3 gives me 1. So my first rate of change is 6 over 1. Then if I do 18 minus 12 is 6. 3 minus 2 is 1. So my second rate of change is 6 over 1. And then if I do 12 minus 6, 2 minus 1, I again get 6 over 1. So all three are the same. So yes, it is linear. There's a constant rate of change. And another table. So this one's going to be a little trickier because there's some negatives in our table, but we can still do the same thing. So change in y over change in x. So negative 10 minus a negative 4. So that's going to have a super plus. So negative 10 plus 4 is negative 6. 14 minus 6 will give me 8. So negative 6 over 8. My first rate of change, so that'd be negative 3/4. All right, my next one, negative 4 minus 1, so negative 5. 6 minus a negative 2 would give me 8. So then I have negative 5 over 8. And you can already see that these don't match, so it's not going to be linear, but I'm just going to do the last one. 1 minus 5 is negative 4. Negative 2 minus a negative 10, super plus, that'd be 8. So negative 4 over 8, which would be negative 1/2. So these three do not have the same rate of change, so it is nonlinear because there is not a constant rate of change. So all three of them have to match for there to be a constant rate of change. Summary.